Welcome us to today's learning. In this video, we'll be learning project management using network model in our Excel spreadsheet. And the objective of this learning or video is to help us determine the project duration in number of days. That is the number of days it will take this project manager to complete this given project. And our assumption here is that every activity has to be done efficiently. That is, the time duration assigned must not be exceeded. The Excel formulas we'll be applying in this course is the max function, the mean function, the sum function, and the ampersand function. So with these functions, we'll be able to determine the earliest finish time for the project and the latest start time for the project. And the activities that will be given for this project is that there's a marketing research manager of a brewing company, which is XYZ Brewing Company, is planning a survey to determine consumer preference of his company's brand as against competing brands. So in this regard, he has determined the following requisite activities and their corresponding duration time, which means that in activity A, he's going to design a questionnaire. Activity B is going to sample the design. C is to pre-test of questionnaire. D, recruiting of interviewers. E, training of interviewers. F, activity is to allocation of areas to interviewers. G, activity is to conduct the interviews, and H is to analyze the data and produce the research report. And this activity, we have them following one after the other, which is the preceding activity, and their time durations to complete this given task. So in total, we see that we have about 68 days in total to complete this project. But we know that in being efficiently, if everybody is to work efficiently, we can take a lesser day aside, lesser than 68 days to complete this project. So using the network model we'll be able to determine that efficient number of days that will take this project to be completed. So in doing that, we'll be employing the forward pass and the backward pass. So we've already designed the network diagram. So to do that, how to do that can be explained in a subsequent video, depending on your comment, if you want to learn how to produce the network diagram. But the network diagram has already been produced, and we have for our earliest finish time, which is represented by the green box, and the latest start time, which is represented by the orange box, okay? And our forward pass is represented by the green arrows. That means at the starting points, it leads to activity A, activity B, activity C, activity F, activity E, D, G, H, and the duration time it will take for this activity to complete, which is given. Like we have our activity A will take us 5 days to perform, B 12 days, and so on. Okay, so our task here is to produce the project duration in number of days that it will take the project to complete. All right, so we'll be doing that using the earliest finish time, and also how to determine the latest start time for the project, which is gotten from the backward pass. All right, so the earliest finish time, which is represented by the green box, which we're about to complete, is, so I have a little definition here to help us, to give us a background information on what we're trying to do. Here, the earliest finish time, which is the EFT of an activity, is the earliest starting time plus the time duration, okay? The earliest starting time plus the time duration of the activity. And the earliest starting time of an activity is the earliest finish time of the preceding activity. All right, so let's demonstrate this. So for the start time, the earliest finishing time, because there is no preceding activity, will be 0. All right. So for activity A, The earliest finish time is the earliest finish time of the preceding activity. So it's the earliest start time of the preceding activity plus the duration of the activity. That is to say, is equal to the earliest finish time of the preceding activity, which is this, plus the duration of the activity, which is 5. So I'll go and select 5 and I'll press my enter key. So for activity A, like we have here, it will take us 5 days to complete because there's no preceding activity. Activity B also, it's the preceding plus the duration of the activity, which is 12. So it will take us 12 days to complete activity B. So for activity C, if you note that activity C is not only feeding event number 4, sorry, this is event 0, event 1, 2, 3, 4, 5, and 6 for the whole of the project cycle. So activity C is not only feeding into event 4, we also have activity F also flows into event 4, and activity E also flows into event 4. But before that, we can determine activity D because it just flows to the next node. To do that, we select this equal to activity, the preceding activity, event number 2 plus the duration of the activity, which is 3. So I'll select 3, press enter. So it will take me 15 days to complete activity D. All right. So now we can then determine what flows into event 4. So so as part of the rule to determine what flows into event 4, we'll be taking the maximum number of either activity C or activity F or activity E. Okay, so we'll be using the maximum number to do that, the maximum function to do that. So we say equal to max, which I said is one of the Excel functions we'll be using, max. I open my bracket, then open my first bracket to get the first argument, which is activity C, preceding activity, plus the duration of the current activity C. Yes, close my bracket, comma, open the next bracket for the next argument, which is activity event 2 for F plus the activity duration, which is 2, close my bracket, comma, open my bracket, then activity E, which is 15 plus the activity duration, which is 5 days. Select my 5 days, close my bracket. Then I close my final bracket for the max function. So in this argument, we have stated that we should have that the results, the formula should return the maximum number of either activity C, which is F6 plus I7, or activity F, which is F16 plus J13, or activity E, which is the summation of J16 plus M13. Then I close my bracket. I press the enter key. So I have 20. So 20 is the maximum. And which one is bringing in 20 is activity E. Activity E, which is 15 plus 5, 20. 12 plus 2 is 14, which is less. And 6 plus 5, which is 11, which is less as well. All right, so activity E flows into event 4. So from here, we can determine the number of days for activity G, which is equal to the 20 preceding activity plus the activity duration or duration of activity, which is 14 days. Press my enter key. So to complete activity G, we need 34 days in total to have completed up to activity G. And activity G is conducting of the interviews. Then the last activity, which is to analyze the data and research report and produce a research report, is to now sum up the preceding activity duration plus the duration of the current activity, which is activity H. All right. So you can see that in total, we have about 55 days to complete this project if everybody is efficient in his or her task assigned, as against the total duration of 68 days if you should sum up all the day's activities. All right, so we've been able to do that using the max function and the sum function. All right, and in doing all of this, we employed the forward pass, which is the green arrow. So, but we may want to determine what is the backward pass, that is the latest starting time. What's the least time to take us to start the project? So by definition here, we said that the latest start time of an activity is the latest finishing time minus the time duration of the activity. And our latest finish time is the latest start time of the successor activity. Remember, we said for the earliest finish time is the preceding activity, but in this case, we are now looking at the successor activity. So to work back, which is the blue arrow, which I've already brought in my network diagram. So I'll just compute my latest start time. So for the finish time is the same as the start time. So I will say equal to this, right? Which is the same 55. So to determine the latest start time for event number 5, I'll come here equal to the succeeding activity, which is 55 minus the duration of activity, which is 21 for activity H. So I'll select 21, press enter. So I have my 34, okay. Then also for activity G, I'll say equal to the succeeding activity 34 minus the duration of activity, which is 14 days. Select my 14 days, press enter. So I have 20. So now this is now the event, the calculation is becoming more interesting as we have so many arrows flying to different event numbers. All right. So this arrow flows solely to event number 1, which means that we can do the same way to calculate the latest starting time, which is the same thing as equal to 20 minus 6. Press the enter key. So we have 14. Then for event number E, there's still just one arrow flowing down that ends here. We can also do the same thing, equal to press succeeding activity minus the duration of activity, 5 days. Press the enter key. 15. Then if we note clearly, we will see that for event number 2, activity F and activity D, they all end in event number 2, which means that for us to determine what the latest start time will be, we need to use the minimum function. That is to say that the minimum of activity F and the minimum of activity D should be returned in our latest starting time. All right, so to do that, we enter the minimum function equals to min, open my bracket. So I open my first bracket to take the first argument, which is 20 minus the event for F, which is 2. Okay, close my bracket, comma, open the next bracket for the next argument. I'll say 15 minus the duration of activity, close my bracket, close my final bracket. So here we've said that we should return the minimum of either activity, the number of days for activity F, or the number of days for activity E, which is for F is 20 minus 2, and for 15, it's 15 minus 3. All right, so the minimum is 15 minus 3, which is 12. Yeah, 20 minus 3 is 18, but we said in our function that we should get the minimum of the 2 activities. All right, so move on to the next empty box, which is our start time. All right, so we have 2 arrows as well, that's 2 backward pass arrows that ends in our starting box. So we also employ the min function to get the latest start time for activity for event number 0. So we'll say equal to min, open a bracket, open our first bracket to get the first argument. That is to say 14 minus the duration of activity for A, which is 5, select 5, close my bracket, comma. and I take the next argument, which is 12 minus the event activity duration, 12 minus 12. Close my bracket and include my final bracket. All right, I press the enter. So we have 0. We have 0. So we'll be able to use the max function, the min function, and the sum function to determine our forward pass and our backward pass to get the project duration. So here, for this project to start at 0 days, was going to be ending at 55 days. So we're now going to bring in the 55 days using the ampersand. All right. So I'll say equal to, select the 55. But note, I want to add days to the 55 to show that it's in 55 days. So I'll use the ampersand to add the days to it. So I'll select equals to the days, which is 55. I will not include the ampersand to it. That is the shift 7 to bring the ampersand sign. So because days will be written in text, I have to include it in the quotation, in a quotation by saying, open my quote, space, and I'll type my days, close my quote, press the enter key. All right. So in all of these analysis we've done, so from design of questionnaire, from day 0 to analyzing of the data and producing the research report, we take us in total 55 days to complete. Thank you for your time. And if you feel, if you have learned a thing or two from this video, kindly hit the subscribe button and click on the like to get more of these videos. Thank you for your time once again.